Hello smart civil engineers, I'm Engineer Masroor and you are watching your own YouTube channel Engineering Network. Today's video is very interesting and important for every civil engineer because in today's video I'm going to calculate the stresses in a column due to the applied load. Now this is very important and very useful in the design of R.C.C column. Okay, so please watch this video completely. Now before I start, if you find this video informative, then please like this video, share it, comment your questions and also subscribe to my channel and press the bell icon for more interesting civil engineering videos. So let's start. Okay, so basically there are two stresses produced in eccentric loaded column. One is the direct stress and second one is the bending stress. Now the direct stress are produced when the load applied along the axis of the column, which will cause tension or compression in the column, right? And bending stress are produced when the load are applied apart from the axis of the column, as you can see on your screen as well. So that load will cause bending in the column, okay? So the direct stress is equal to sigma naught is equal to P by A. Here P is the applied load and A is the cross-section area. And bending stress is equal to sigma B is equal to 6 PE divided by AB. Here P is again the applied load, E is the eccentricity, and A is the cross-section area and B is the width of the column, right? Now total stress is equal to sigma is equal to minus sigma naught plus minus sigma B. Now if I put the formulas of sigma naught and sigma B here, then sigma is equal to minus P by A plus minus 6 PE divided by AB. Now if I split this equation, then sigma maximum is equal to minus P by A minus 6 PE divided by AB, right? Now if I take minus P by A common, then sigma maximum will become minus P by A into 1 plus 6E divided by B, right? And similarly, sigma minimum is equal to minus P by A into 1 minus 6E divided by E, okay? So I have got two formulas. One is sigma maximum and second one is the sigma minimum. Now I will use both these formulas and calculate the stresses produced in eccentric loaded column, right? Now also keep in mind that if direct stress is greater than the bending stress, then the stresses in that column will be in compression. And if the direct stress is equal to the bending stress, then the stresses will be of same nature. And if the direct stress is less than the bending stress, then the stresses in the column will change its sign, which means that they will be partially compressive and partially tensile, right? So please keep these points in your mind. So now let's solve few numerical questions. The question states that a rectangular column is 15 cm wide and 12 cm thick. It carries a load of 18 tons at an eccentricity of 1 cm in a plane bisecting the thickness. Find the maximum and minimum intensity of stress in the section. Now in order to solve this question, first I have to calculate the direct stress and bending stress, and I will check whether the stresses produced in the section will be compressive or tensile, or both compressive and tensile, right? So the direct stress is equal to P by A. Here P is the applied load, which is 18 ton. And if I convert it to kg, then simply I will multiply it with 1000. And the applied load will become 18,000 kg. Okay? Area of the section is 15 into 12, which is equal to 180 centimeter square, right? So the direct stress is equal to 18,000 divided by 180, and it will become 100 kg per centimeter square, right? Next is the bending stress. So the bending stress is equal to 6 PE divided by AB. The bending stress is equal to 6 into 18,000 into 1, which is the eccentricity, divided by 180 into 15. Okay? And after solving it, the bending stress will become 40 kg per centimeter square. Okay? Now if you look at here, the direct stress is greater than the bending stress, which means that the stresses produced in the section will be compressive. Okay? Now let's find out the maximum and minimum stresses in the column. So sigma maximum is equal to minus P by A into 1 plus 6E by B. Here I have all the required data. So sigma maximum is equal to minus 18,000 divided by 180 into 1 plus 6 into 1 divided by 15. And after calculation, sigma maximum will become minus 140 kg per centimeter square, right? Similarly, sigma minimum is equal to minus P by A into 1 minus 6E divided by B. So sigma minimum is equal to minus 18,000 divided by 180 into 1 minus 6 into 1 divided by 15. And after solving it, sigma minimum will become minus 60 kg per centimeter square, right? Now here both maximum and minimum stresses in the section are negative, which indicates that both stresses are in compression, right? Now if I draw the stress diagram for this column, then first I will draw column, okay? Here 18-ton load is applied with 1 cm eccentricity away from the axis of the column, okay? And this is the cross section of the column with depth of 12 cm and width of 15 cm, right? Now for the stress diagram, as both maximum and minimum stress are in compression, so the stress will be below the neutral axis, right? So I will start from here with the sigma minimum, which is minus 60 kg per centimeter square, and here I will put sigma maximum with minus 140 kg per centimeter square. Okay, so this is the stress diagram of this column. So guys, as you can see, this is how you can easily calculate stresses in the column. I hope you would find this video interesting and informative. So please like this video, share it, and if you are new, then please subscribe and also press the bell icon for more interesting civil engineering videos. See you in the next video.